So, first one, drift velocity. What is drift velocity? Very important topic. Drift velocity. What is drift velocity? If you are connecting a conductor to what is this? This is a battery. It will be giving out a potential difference. If you are connecting a conductor to a potential difference, that means you are applying an electric field. If an electric field is applied, the electrons will be moving opposite to the electric field. Electrons will be moving opposite to the electric field, and the electron will be having an average energy. Sorry, average velocity. That average velocity is called drift velocity. To derive an equation for drift velocity, there is a derivation. What is that? That derivation is this derivation of the drift velocity. So you have to study that. I'm not repeating it. Derivation of the drift velocity. That's very important. It's not this complicated. It is not that complicated. Not this much complicated. You can stick to the derivation that we have done. You can stick to the derivation that we have done. We have using the same idea of force. Like this. Remember that derivation for drift velocity. Derivation for drift velocity. Where did we start? This is a conductor. And that conductor is connected to a positive and negative terminal. And this is electric field applied in this direction. Electric field is always from positive to negative. Electric field is from positive to negative. What about the electrons? Electrons will be moving in opposite direction of the electric field. It is moving in this direction. The electrons are moving in this direction. Now, what is the average velocity of electrons? If you average velocity of electrons are zero. Why? Why average velocity of electrons are zero? Electrons will be average velocity without electric field. This is actually without electric field. Without electric field, the average velocity of electrons will be zero. Why it is zero? Why average velocity of electrons are zero without electric field? If there is no electric field, electrons will be in random motion. If there is no electric field, electrons will be in random motion. What I am doing here, this is the derivation for drift velocity. Derivation for equation for drift velocity. If there is no electric field, the average velocity will be zero. The electrons will be in random motion. One electron will be in that direction, one will be in this direction, one will be upwards, one will be downward. So the velocity will be cancelling. Average velocity will be zero. Now, with the electric field. Electric field is applied. When an electric field is applied, what happens? When an electric field is applied, electron will be having an average velocity. Average velocity will not be zero. Average velocity will not be zero. How to find that average velocity? That average velocity will be like this. Average velocity is equal to V is equal to U plus AT. So U average plus A into T average. This is the equation with which you can find the drift velocity. Clear? Okay. Now you know what is the value of average initial velocity. That's zero. And acceleration. You need to find acceleration. How to find acceleration? You know the equation for force. Force is equal to mass into acceleration. Okay. What is electrostatic force? Electrostatic force. Electric force applied on this object. That will be Q times E. That will be Q times E. So you can combine these equations. MA and QE can be combined. So you will get A. What is A? Now Q can be written as E. What is Q? Charge. Charge is charge of electron. So this is E. What is this? This is E. And A can be written as E. So there will be a minus because the charge of electron is negative. Then what is acceleration? Acceleration is equal to minus E by M. This is acceleration. Acceleration is equal to minus E by M. Yeah. Now you can use that here. V average is equal to U average is 0 minus E by M T average. What is T average? Average time interval between two successive collisions. What is that? It's called relaxation time. What is T? Tau is relaxation relaxation time. Relaxation time. What is relaxation time? Average time interval between two successive collisions. That's relaxation time. Now we have the equation for average velocity. What is average velocity acquired by the electrons when electric field is applied? When electric field is applied, the velocity of the electrons is actually drift velocity. So this is drift velocity. Drift velocity is equal to minus E by m dot tau. This is the equation for drift velocity. It's not that complicated derivation. It's a very simple derivation. Okay? Yeah, it's a simple derivation. Without electric field, the average velocity of the electrons will be 0. With the electric field, average velocity can be written as U average plus A into T average. And this is V average is equal to U average plus A into T average. Okay? Now we are finding the force on the electron. That's Ma. Force, electric force is equal to QE. Q is equal to charge of electron. So if you write Ma is equal to QE, Ma is equal to minus E, A is equal to minus E by N. The average is equal to average plus A into T average. The average is equal to 0 plus minus E by M tau. What is tau? Tau is relaxation time. The average time interval between two successive collisions. Now you can write the equation VT. Drift velocity is equal to minus E by M tau. Clear? Drift velocity is equal to minus E by M tau. Minus E by M tau. Minus E by M tau. Clear? I'll use a darker color after this. That's better in the board, better in the camera. Got it? So that's it. Now let's do the next important derivation. This is the derivation for drift velocity. So that's the drift velocity derivation. Then there is relation between drift velocity and electric current. Are you able to do that? Relation between drift velocity and current. Can you do that? Drift velocity and current. Do you have that one? Drift velocity and current. Relation between drift velocity and current. Relation between drift velocity and current. Can you write? Relation between drift velocity and current. Do you have drift velocity and current? Yeah. Drift velocity and current. I'll be that. I'll be that. What is the starting point? Where it will start? This is a conductor, battery, cell. Okay, conductor, battery, cell. Then, yes, this is the length of the conductor. What is that? L? L is the length of the conductor. And if the electrons are here, the electrons will be moving in the opposite direction of the electric field. Now, if the electrons are moving in the opposite direction of the electric field, yes, current is in the opposite direction. Let us say current. This average velocity of the electron can be taken as drift velocity. So this length can be written as drift velocity into time, because distance is equal to velocity into time. Distance is equal to velocity into time. Like that, you can write length is equal to velocity into time. Right? Okay. Now we have that. Electric field is separated here. Now we are starting from small n. What is small n? Huh? No. That's called number density. Small n is number density. Number of electrons per unit volume. What is n? Number of electrons per unit volume. N divided by volume. What is this? N divided by volume. N divided by volume. What is volume? What is volume? No, volume is, this is area. Area into length is volume. Area into length is volume. Yeah, area into length is volume. If volume is area into length, then you can write volume as area into what is length? Length is VDT. Length is VDT. So you can write capital N. Capital N is equal to N into volume. N into volume. N into what is volume? A into VDT. A into VD into T. Clear? That is capital N. What is capital N? Number of electrons. What is capital N? Capital N is number of electrons. Capital N is number of electrons. Clear? Number of electrons. Now you have capital N, number of electrons. If you have number of electrons, what is the charge? What is the charge? Q is equal to N. Q is equal to Ne. Q is equal to Ne. Number of electrons into E. So what is Q? Q is equal to N. What is N? N is small n into A into BD into T. That's N into E. That's Q. Q is charge. What is current? Now you have charge. Let's find current. What is current? I is equal to Q by T. So I is equal to what is Q? N A B D T E by T. So the T is gone. So I is equal to what? A B D E N. What is I? I is equal to A B D E N. Did you understand this? This is the derivation or relation between drift velocity and current. Remember this? Relation between drift velocity and current. I is equal to A B D E N. Very good. I is equal to A B D E N. Everything is okay? Yes. Then that is the second derivation. And second derivation, fourth one. Electric current and current density. Electric current and current density. It's not that complicated. Electric current and current density. This is what? This is what? I, current. Current is equal to AVDEN. Now you can write current density. Current density. What is current density? That's J. Current density is J. What is current density? Current density J is equal to I by A. Current per unit area. That's current density. Current per unit area is current density. So what will be that? Current density J is equal to I by A. What is I? AVDEN by A. A and A is gone. J is equal to VDEN. J is equal to VDEN. You can use this derivation. This derivation is simpler. So you can use this one. What is current density J? J is current per unit area I by A. So you can use AVDEN divided by A. A and A is gone. VDEN that's J. That's J. Is this derivation okay? Especially, is it okay? If they are asking you to derive the relation between current density and drift velocity, you can start from this and end here. If they are asking you to derive the relation between current and drift velocity, you can end here. The same derivation can be used for both. There is different kinds of derivation methods are there. You can use this one. See, there will be different types of derivations. The derivation you will be seeing here will be different. The derivation you will be seeing here will be different. This is another type of derivation. You don't have to use that. Use which is simpler. Use the simpler derivation. Okay. Now, cells in series. Cells in series. Cells in series. Look at the final equation. Cells in series. The EMF can be added. Cells in series. The EMF can be added. Study that. You can use V is equal to V1 plus V2. Voltage can be added. Just like that. Yeah. The voltage here will be E1 minus I into R1. This study this one. V is equal to E minus IR. What is that? E minus IR. What is V? Applied voltage. What is E? EMF. Both of them are different. Applied voltage and EMF are different. What is V? V is applied voltage, E is EMF. E minus IR. What is this? Applied voltage will be EMF minus I into R. What is this R? R is internal resistance. R is internal resistance. If you take a cell, that cell will be having an internal resistance. Okay? Okay? Yes. And what is the relation connecting this voltage and EMF? Voltage and EMF? Voltage is equal to E minus IR. That means voltage will be less than EMF. Voltage will be less than EMF because there is internal resistance. Clear? Using that, we are doing the derivation. The derivation is same, so I am not doing that. Same derivation. Same derivation. I am not doing that. You can study this one. Same one. Okay? Now, resistances in parallel. Resistances in parallel. This is just sorry, not resistances in parallel. Cells in parallel. Cells in parallel. What is this? Cells in parallel. If the cells are in parallel, who is splitting? Current is splitting. Who is splitting? Current is splitting. I will be splitting into I1 and I2. See that? I is splitting into I1 and I2. So I is equal to I1 plus I2. Yeah. The I current is splitting into I1 plus I1 and I2. So for first cell, you can find I1. Second cell I2. Then you can add the. This is the same derivation we have studied also. Same derivation. You can study this derivation. This is simple one. So you will get R. What is R? R is equal or E. What is E? E1 R2 plus E2 R1 by R plus R. What is EMF? What is EMF? EMF will be this is the EMF. This is the EMF. The combination EMF. Combination EMF will be, we wrote it like this. Combined EMF will be E1 R2 plus E2 R1 divided by R1 plus R2. This is when the cells are connected in parallel. This is when the cells are connected in parallel. Understood? When the cells are connected in parallel. If this comes in any other questions, we will do it again. You can study this derivation. This derivation is okay. We studied the same derivation in the class, in the regular class. So use the same derivation. Clear? Now, Weissted's bridge. Weissted's bridge. What is that? Weissted's bridge. Weissted's bridge derivation. Yeah, they are using the same derivation. No. Yeah. Weissted's bridge derivation. You remember that? Weissted's bridge derivation was very simple derivation. Or is Weissted's bridge. Weissted's bridge. So what was Weissted's bridge derivation? Very simple derivation was the. You remember that? This is Weissted's bridge. Weissted's bridge. What is the use of Weissted's bridge? To find unknown resistance. To find unknown resistance. To find unknown resistance. This is P, Q, R, S. We are connecting them by a cell, positive or negative. Now there is a galvanometer here connected like this. Now this is A, B, C, D, A, B, C, D. Okay. Now the current. If I mark the current, how to mark the current? Current is starting from here, and here current is splitting I1 and let's current split here. Let current split here. Here also current splits. Now at here it's combining, and here also it is combining going like this. Now name it I1, I2, I3, I4. I1, I2, I3. I1, I2, I3. Clear? What is the current passing through galvanometer? That's Ig. What is the current passing through galvanometer? That's Ig. Now apply Kirchhoff's first rule. Apply Kirchhoff's first rule at B. Apply Kirchhoff's first rule at B. Yeah. At B. What is Kirchhoff's first rule at B? I1 is equal to I2 plus Ig. I1 is equal to I2 plus Ig. Clear? Yes. Now, Kirchhoff's first rule at B. What is happening at B? I3 is coming, Ig is coming, I4 is going. So, yeah. So you can write I4 is equal to I3 plus Ig. I3 plus Ig. I3 and Ig are coming, I4 is going. Okay? So I4 is equal to I3 plus Ig. Clear? Clear? No? What is this point? This point is B. At D, IG is coming to D, I3 is coming to D, I4 is going away from D. So I4 is I3 plus I3. Clear? Okay, now apply Kirchhoff's second rule. Kirchhoff's second rule. Second rule should be applied on loops. Which loop we are selecting first? A, B, D, A. In loop A, B, D, A. In loop A, B, D, A. What is the equation of loop A, B, D, A? I1P, first voltage. I1P is the first voltage. I1P plus. Now, IgG. What is G? G is galvanometer resistance. Galvanometer resistance. G is galvanometer resistance. Clear? G is galvanometer resistance. In loop A, I1P is the first voltage. What is the second voltage? IgG is the second voltage. This is the same direction. Same direction. And here B to A current is in the opposite direction. So you have to take that voltage as negative. Then it will be minus I3R. Minus I3R is equal to 0. Because we are going from B to A, current is going from A to B. Current is in our opposite direction. If current is in our opposite direction, that voltage has to be taken negative. Okay? Yes. Then another loop. In loop D, C, D, B. In loop D, C, D, B. In loop D, C, D, B. What is the first voltage? What is the first voltage? I2Q. That's basically why I am going from B to C. Current is going from B to C. So that voltage is positive. I2Q. I2Q minus I4S. Why is I4S minus? Because I am from C to D, current is in opposite direction. So minus I4S. Now D to B, IgG. IgG is positive or negative? Negative, right? I am moving from B to B, current is in opposite direction. So I can take it as negative. IgG is equal to 0. Okay? I am applying the Kirchhoff's second rule here and here. Okay. Now, what is the next step? Imagine Q is the unknown resistance. Imagine Q is the unknown resistance. How to find this unknown resistance? We can adjust the resistors. We can adjust the resistance. Maybe this resistor is variable resistor. So we can adjust the resistors. Okay. So the next point will be adjust the resistors. Adjust the resistors. Why we are adjusting the resistor? Yeah, we can no. We are adjusting the resistor to make the galvanometer current 0. Okay, adjust the resistors to make galvanometer current is equal to 0. That's Ig is equal to 0. It has a name. What is the name of the condition? Balancing condition. What is the name? Balancing condition. Balancing condition. So that bridge is balanced. What is it? The bridge is balanced. Balancing condition. Now, if Ig is 0, I1 equal to Ig, I4 is equal to I3. I4 is equal to I3. If Ig is 0, this is my first equation, my second equation. From first and second equation, I will get Ig is gone. From first and second equation, I will get Ig is gone. So I1P is equal to I3R. Minus I3R can be taken here. So it will become plus I3R. Now I1P is equal to I3R. I can write from here I1P is equal to I3R. Got it? I1P is equal to I3R. From the second equation, I will get IgG is gone. It's 0. It's gone. So I2Q plus minus I4S coming to the other side. Plus I4S. So I2Q is equal to I2Q is equal to I4S. I2Q is equal to I4S. That's my equation number 3 and 4. Now I'm at the end of my derivation. What I have to do? Just divide one equation from the other. Just divide 3 by 4. How to get that? How to do that? I1P by I2Q is equal to I3R by I4S. Clear? Yeah? Yes. Then I1 and I2 will be gone by, because I1 is equal to I2. Why I1 is equal to I2? Why I1 is equal to I2? Ig is 0. If Ig is 0, I1 is equal to I2. And I3 is equal to I4. Why I3 is equal to I4? Ig is 0. Ig is 0, I4 is equal to I3. Then I3 and I4 can be done. I will get P by Q is equal to R by S. P by Q is equal to R by S. Got it? P by Q is equal to R by S. How is this derivation? So, which are the important derivations from this chapter? First derivation is the derivation for drift velocity. Study that. Derivation for the drift velocity. Second one, relation between current and drift velocity. Then relation between current density and drift velocity. Both of them are the same derivation. Okay. Then internal resistance in series, internal resistance in parallel. Then distance relation. 5 derivations. 5 derivations are very important. There are other derivations also. These 5 derivations are very important. Clear? Okay. Now can we go to MCQ part? Okay. See this. See the MCQs. MCQs. First one. First one. What is that? Current of 4.8 ampere is flowing through a conductor. The number of electrons per second will be found. We are using quantization of electric charge here. We are using quantization of electric charge here. You can use quantization of electric charge to find the value. Find the value. Which equation you will be using? Yes. Amina, Neha, when you get the answer, just type that in the chat box. I will see that, okay? Got it? 3 to 10 raised to 90. Maybe. I'm not remembering the answer. I should do it. Clear? Got it? And MCQ, not much time for that. You have to do numericals also. No, it's not about maths. You can memorize this value. There will be 1 by 1.6 will be there. You don't have to do that. Memorize this value. 1 by 1.6 will be 0.625. Memorize that. 1 by 1.6 will be, yeah, 1 by 1.6 will be 0.625. So remember that. Remember the answer? Current of 4.8 amperes is going to be conducted the number of electrons per second. Per second means time is 1 second. Per second means time is 1 second. So, what is that? First question, current. Option A. Okay, Meena. Current I is equal to 4.8 ampere. Time is equal to 1 second. And what are they asking? What is the number of electrons passing? They are asking what is the number of electrons passing. Q is equal to NE. We have that. We have the equation for Q. What is Q? Q is equal to NE. Q is equal to NE. Q is equal to NE. If Q is equal to NE, what is N? N is equal to Q by E. N is equal to Q by E. We need Q. We don't have Q. How to find Q? I is equal to Q by T. So Q is equal to I into T. What is I? I is 4.8 into 1. So what is Q? 4.8. Q is what? Q is 4.8. Coulomb. 4.8 coulomb. Yes. So N is equal to 4.8 divided by E. What is E? Yeah, 1.6 into 10 raised to minus 90. 10 raised to minus 19. 10 raised to minus 19. How to do this? 1 by 1.6 is that 1 by 1.6 is 0.625. So 0.625 into 4.8 into bring this 10 raised to minus 19 upwards. What happens? It will become 10 raised to 90. So what is this? 4.8 into 625. 4.8 into 625. Are you getting 3? That will be 3 into 10 raised to 90. 3 into 10 raised to 90. This is the number of electrons. This is the number of electrons. Right? This is the number of electrons. Everything is okay. Got it? Look at the next question. Look at the next question. The next question. Next one. What is this? When the current, the I is flowing through a conductor, the drift velocity is V. It's not U. It's written as mu, but it's V. If Qi current is flowing through the same metal but having double the area of cross section, then drift velocity will be 1. Current I is flowing through a conductor. Current I is flowing through a conductor. Current I is flowing through a conductor. Drift velocity is V. If Qi current is flowing, so which equation you will be using? Which equation?
It's V. You use I equal to AB,
There is only I and B, so you can use ABDEN. Use that. What is the answer? C. Current I is flowing through a conductor. I is equal to what? I is equal to ABDEN. Clear? So what is the relation between current and drift velocity? That's the main point. What is the relation between current and drift velocity? Same metal, but having double the area of cross section. Double the area of cross section. Okay? Then drift velocity will be. So area is changing, drift velocity is changing. Having double, then the drift velocity will be. What is the relation between drift velocity and current also is changing? Current also is changing. So what is the first one? First equation? I is equal to A B D E. First equation. That is the first equation. First equation. Now the second equation. What is the second equation? Second equation is QI. Current is QI. What is area? Double the area is going to A. BD. Just BD dash. Because drift velocity has changed. You cannot give BD. BD has become B dash. BD dash. Another one. Okay. EN. E and N are constants. They are not changing. E is charge of electron. N is number density. They are not changing. They are constants. So this is the second equation. Did you understand the second equation? First one is just I is equal to ABDEN. We know that. Second equation is 2 times I is equal to 2 times A into BDEN. Clear? Clear? Okay. Now what happens in this equation? This 2 and this 2 will be gone. And 2 and 2 are gone. So what is that? I is equal to A BD dash EN. Look at these two equations. Look at the equations. I, A, BD, BD dash, E, N, N. That means BD is equal to BD dash. BD is equal to BD dash. That means drift velocity is not changing. Drift velocity is not changing. Understood? Drift velocity is not changing. If drift velocity is not changing, then the second drift velocity will be just V. Second drift velocity also will be just V. That will be just V. Okay? Here the drift velocity is just V. So the second drift velocity will also be V. Understood? Okay. Amina, Neha. Everything is okay, right?
Yes, sir.
Yes, sir. Now, the next one. The next one. The next one. Third one. Yeah, that's not a calculation question. You have to remember this value. When the current is flowing through a conductor, then the order of drift velocity of electrons will be. Order of drift velocity. Order of drift velocity of electron. Remember that order of drift velocity. You may have that. Found it? Got it? You have to remember something very centimeter. You may have studied that in meter per second. We have studied that in meter per second. So what is the answer? First one is the answer? No. Temperature is a very large value. It's not a very large value. It's a very small value. Drift velocity is a small value. This is centimeter per second.
Let's see.
One is meter per second, the other one is centimeter per second. C 10⁴ centimeter per second. What is the actual value in meter per second? What is the actual value? Amina. Neha, what is the actual value in meter per second? We have studied that. 10⁻⁻⁴ meter per second. 10⁻⁻⁴ meter per second is the value. 10⁻⁻⁴ meter per second is the value. Okay, but that is in meter. There is no 10⁻⁴. So convert that into centimeter. How to convert meter into centimeter? Into 10 raised to minus 2 centimeter per second. Now, if it is centimeter per second, then it will become 10 raised to minus 6 centimeter per second. So when you 10 raised to minus 6,
Sir, isn't it 10 raised to
10 raised to
just 2, not minus?
10 raised to
Isn't it just 10 raised to 2, not minus 2?
this one.
No, the conversion. And 10 raised to minus.
Okay. Sorry. Meter into centimeter. Yes. Meter into centimeter. So that will become 10 raised to 2. So minus 4 and plus 7. That will become 10 raised to minus 2 centimeters. Yes. 10 raised to minus 2 centimeters. Now we have to convert a meter into centimeter. How to convert meter into centimeter? Into 10 raised to 2. Centimeter into meter is 10 raised to minus 2. Okay. So meter into centimeter is 10 raised to 2. 1 meter is equal to 10 raised to 2 centimeter. So this is the conversion. This is the conversion. Then 10 raised to minus 4 into 10 raised to 2, that will be 10 raised to minus 4. Clear? What is the answer then? This is the answer. 10 raised to minus 2 is the answer. Okay. So remember this value. What is this? 10 raised to minus 4 meter per second. What is 10 raised to minus 4 meter per second? That's the order of magnitude of drift to velocity of electrons. What is that? Order of magnitude of drift to velocity of electrons. Drift to velocity of electron will be of the order of 10 raised to minus 4 meter per second. Clear? Now, look at the next question. Follow. Look at the fourth. With that, the resistivity of iron is 1 into 10 raised to minus 7 ohm meter. Resistance of an iron wire of particular length and thickness is 1 ohm. If the length and diameter of wire both are doubled, then the resistivity will be what? Read the question and find the answer. Amina, Neha, if you have the answer, just tell me that. Just let me know that if you have the answer. Read the question. Vaishnav, read the question. No, don't look at the answer. Read the question. Neha? Meena? Do you have the answer? Sarah? Vaishnavi? Amina, don't do. There is no calculation. Just look at the answer. Just look at the question.
minus 7.
Don't think too much, guys. What is this question? Resistivity of iron rho is 1 into 10 raised to minus 7 ohm meter. Resistance of iron wire of particular length and thickness. Resistance is given 1 ohm. If the length and diameter of the wire both are doubled, then the resistivity in ohm meter will be. What is this? What is this? Resistivity. What is this? Resistivity. What is this? Resistivity. Resistivity cannot be changed if the length or diameter changes. Resistivity is a constant. It's a constant. It's not changing. Resistivity depends on temperature. Resistivity depends on temperature. If the temperature is not changing, then the resistivity is a constant. So the resistivity does not change. Then the value is what? What is the answer? It will be same. 1 into 10 raised to minus 7. It will be same. Rho is equal to R A by L. Right? What is this equation for? This equation is to find the resistivity if resistance, area, and length is given. If the length and diameter of wire both are double, that's the same material. That's the same material. If that's the same material, resistivity cannot change. Okay? This is an equation. This equation is to find the resistivity if resistance, area, and length is given. Yeah, they are given. It's given. And even if the resistance and the area or length, everything is changing, the resistivity will be self-adjusting. It will not be changing. Sure? Resistivity is a constant. Resistivity is not a constant, but resistivity depends on temperature, not on area or length. Resistivity depends on temperature, not on area or length. Did you understand this, Amina Neha?
Yes, sir.
Yes. Okay, then the next one. Next question. That's the fourth one. Okay, the next question. Fifth one. A piece of wire of resistance 4 ohm is bent to 180 degree at its midpoint, and two halves are twisted together. Then the resistance is what? A piece of wire of resistance 4 ohm is bent through 180 degree at its midpoint and we want to. This is a piece of wire. At the midpoint, it is bent at 180 degree. If it is bent at 180 degree, it will be like this. Bent at 180 degree. See? Okay. And the two halves are twisted together. They are twisted together. So it's just like one single piece now. Then the resistance is what? 2 ohm. Yes. What about length? Length becomes half. So you have to do that. What is this length? Original length is L. Original length is L. Yeah. Original length is L. Original resistance is rho L by A. Isn't it? Now they are twisting it. You are cutting the middle. 180 twisting it. So the resistance must be changed. Rho cannot change because the same material. The length has changed. Length has become L by 2. So L by 2. Length has become L by 2. What about area? Yeah, area becomes 2A. So by 2A. 2A. What happens? This is rho L by 2. Take the rest of 2 by A. That will be 1 by 2. 2A by what? 1 by 2. So what is 2 into 1 by 4. 1 by 4 rho L by 3. That's R dash. Okay? R dash is equal to 1 by 4. What is rho L by 8? R. What is R? 4 ohm. C1 so equal to 4. So what is R dash? 1. Understood? Got it? Amina, Neha? Did you understand this one?
Yes, sir.
Okay. So that's it. Right? You have to imagine that they are cutting at the middle and 180 degree twisted. So the length becomes half. So area of cross section doubles. Area cross section doubles. Then use that in the equation. Rho into L by 2 by 2. Do the calculation. Okay. Now that was the 50 question, right? Now look at the sixth one. Look at the sixth one. Ah, this is it. This is it. Read it. Read it. Read it. Resistance of wire is R. The length of the wire is doubled by stretch. Then new resistance will be. New resistance will be. And what is it, Amina Neha?
Yes. That is 4.
What is happening here? What is happening here? Resistance of the wire is R. If the length of the wire is doubled by stretching it, length becomes that's L dash. L dash becomes 2L. If you are stretching a wire, length increases. What happens to area? Decreases. Yeah. If length doubles, area becomes half. How? 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 Volume will be a constant if you are stretching it or compressing it. Volume is not changing. If volume is not changing, old volume is equal to new volume. A into L is old volume. New volume is A dash L dash. They will be equal. So old volume is equal to A dash into what is L dash? It has doubled. Length has doubled. So 2L. Now the L is gone. A dash is equal to A by 2. This is the idea. Or you can just simply state it like this. Length doubles, area becomes half. Length triples, area becomes 1 by 3. Clear? Okay. And if you use this in new equation, R dash is equal to rho L dash by A dash. What is rho L dash? L dash is 2L divided by A dash is A by 2. So what will be that? 2 is coming down. So 4 rho L by A. That's R dash. Yeah, that will be R dash is equal to 4 times R. Did you understand this? Did you get this? Now I am going to give you a new equation for this, a simpler equation. It's an MCQ, right? So you can use a simpler equation. That simpler equation is R dash will be n square times R. Simpler equation. Such a type of question can be done by R dash is equal to n square times R. What is this n? How many times the length is increasing? What is n? What is n? N is what is n? N is how many times length increases. Length increases. Length increases 2 times. So 2 square, that is 4R. If length increases 3 times, new length is 3 times the old length. What will be new resistance? R dash. What will be new resistance? What will be new resistance? 9R. New resistance will be 9R. Why? R dash is equal to n square R. R dash is equal to n. What is n? 3. 3 square R. R dash is equal to 9R. You don't have to do this calculation. You don't have to do this calculation. You can use this equation. If this is an MCQ. Okay? This equation can be used in MCQ to find the answer directly. Similar equation. Is it okay? This is okay? Neha, Meena, is this one okay?
Yes, sir.
Yes. So remember this one. Remember this equation. R dash is equal to n square times R. N square times R. Now, seven what? What is it? Cold here. Till the little bit hot. Then increase the temperature. Yeah, but there will be sound coming. Sound will be. No. Okay. Look at this question. Second one. Second one. Sigma 1 and sigma 2 are the electrical conductivity of germanium and sodium respectively. Germanium and sodium. If these substances are heated, then what happens to sigma 1 and sigma 2? That's the question. Huh? Look at the sigma 1, sigma 2, the electrical conductivity of germanium and sodium. So sigma 1 is for germanium, sigma 2 is for sodium. Sigma 1 is for germanium, sigma 2 is for sodium. What is sigma? What is sigma? Conductivity. Conductivity. Temperature increases. Heated. Temperature increases. Huh? Both of them are decreasing?
No. So maybe increasing and then
Yeah. What is the relation between conductivity of a metal and its temperature? Or resistivity? That's in the temperature and resistivity for metal. For metal, how is it? Temperature and resistivity. They are directly proportional. That's temperature and resistivity are proportional for metal. How about semiconductor? Yes. For semiconductor, resistivity and temperature are inversely proportional. If temperature increases, resistivity decreases. And conductivity is reciprocal of resistivity. Okay. So what about conductivity? Conductivity is inversely proportional to temperature here. Conductivity is directly proportional to temperature. This is the idea. This is the idea. What is germanium? Germanium semiconductor. Germanium is a semiconductor. And sodium a metal. Sodium is a metal. So for the semiconductor germanium, what happens if temperature increases? Conductivity increases. Conductivity increases for germanium. For germanium, temperature increases, conductivity increases. Conductivity increases. For sodium, temperature increases, conductivity decreases. Clear? Yeah. Understood? Yeah. That's it. Then, 8th question, you don't have to look at the 8th question because it is deleted. It is deleted. Color coding of resistors is deleted. Now, 9th question. The alloys constant and manganese are used to make standard resistance due to they have low resistivity, high resistivity, low temperature coefficient of resistance, both B and C. What is this? Constant and manganese. Constant and manganese. Who are they? Constant and manganese. Who are they? They are metal alloys. They are metal alloys. What is the graph for resistivity and temperature for them? What is the graph for resistivity and temperature for them? Almost constant. almost constant. That means even if the temperature is increasing, resistivity is not changing that much. Why resistivity is not changing that much? With the temperature, rise of temperature, there is something called alpha. What is alpha? Temperature coefficient curve. What is alpha? Temperature coefficient curve. There is one equation like this. Rho T is equal to rho 0 into 1 plus alpha into T minus T0. Remember this equation? Remember this equation? Rho T is equal to rho 0 into 1 plus alpha into T minus T0. What is this alpha unit? Temperature coefficient. For alloys, the temperature coefficient is very low. Low temperature coefficient. Then this will be almost negligible. Alpha into delta T will be negligible. Then rho 0 into 1. That's rho 0. So for alloys, rho T will be rho 0. What is rho T and rho 0? What is rho T and rho 0? Rho T is resistivity at a temperature T. Rho 0 is resistivity at a lower temperature. Rho 0. T0. Yeah. T0 is lower temperature. When temperature increases, that is T. Okay? It's like this. At T0, resistivity is rho 0. At T, resistivity is rho. Clear? Okay? For constant and manganese like alloys, alpha is very low. If alpha is very low, this low value into change in temperature will be almost negligible, almost equal to 0. A very low value into change in temperature will be almost 0. So you can neglect that term, then rho T will become rho 0. Resistivity at T temperature will become equal to resistivity at T0 temperature. Not much change in resistivity. Not much change in resistivity. Clear? So you have studied many things from this question. What is it? The graph of alloys. What is this? Graph of alloys. Resistivity, temperature, almost a constant. Almost a constant. That's almost a constant line. Almost a constant. A small inclination is a very small inclination. And they will be having high resistivity. For pure metals, have studied that in chemistry. Maybe you may have studied in pure metals, the resistivity will be lesser. If you are combining the metals, you will get alloy. For alloy, resistivity will be high. For metal alloys, resistivity will be high. Clear? No? Yes. So high resistivity and low temperature coefficient. So what will be the answer? Yeah, both B and C will be the answer. Both B and C will be the answer. Clear? Understood? You can take a small break. After the break, we will complete this and we will do some numericals. Just take a 10-minute break. Okay. So 10 now. We will continue our session at 8 now. We will continue our session at 8:10.